As the second example for break-even analysis, we have this one that you already know, that we have analyzed this case with the benefit cost ratio, and you know about the answer. And now we want to do a break-even analysis on that. I encourage you to do it yourself because it's very insightful and very rich type of activity for break-even analysis. And what you are supposed to do here, please go ahead and do the break-even analysis if the useful life of the project N is uncertain, and do it for different numbers. Start from 5 and go ahead and see what's happened. Exactly, go with the same rules and techniques and style that we have used. You need to have one row for the different values of N, 5, 10, 15, and like that it goes, and right turn lanes present worth and left turn lanes present worth. And you can use present worth, you can use equivalent uniform annual cost, but I suggest use one of these two things. And remember, when you have all these numbers, visualization is not a big deal. Just to tell you, for example, here, if we have N, 5, 10, 15, 20, and we have right lane present worth and we have left lane present worth, and here you have all that data here, and you draw them, and when you draw them, you get things like this, for example, and here is the break-even point, and after this one of them is better, and on the other side the another one. If you are not sure about doing this type of thing, feel free to reach out to me. And so it is just a ready type of example now for you, that please stop the video and start working on that before I show you the answers in this video shortly. Okay, here is the answer to this question. There is really no specific point, so I explained them to you. So you just go before the net present worth of the right lane, as you can see happens here. Initial investment, initial cost, and these are some annual costs that happens. About the benefits and maintenance, you get them, and you get all the present words. And for the for the left lane also you do the same thing. And here is also the visualization. When you look at this chart on the right, you find that it talks thousands of words. And when you look at these, first of all, they are net present worth, okay? And also in the chart should have specified which one is right lane and which one is the left lane, but it has not, but no problem. It is net present worth, okay? So when here it says that in this range right turn is selected, it means that right turn has higher return. So the solid line is right, the solid line is right, and the dashed line is left. Now let's check it together. For the solid line, before 11, about 12, before about 12 years, it is not economic, so it means that it doesn't worth go for all this investment if the life of project is less than 12 years, because you are getting annual benefit of 1.6 million. So if it is a small number, it means that you are losing that benefit sooner. But after that, the right lane project becomes profitable. So after 12 years of life, it's good. The other one, that is the left lane project, after about 13 years, as you can see, it becomes economic, because before that the net present worth is negative, below zero. So it doesn't make sense to invest on that below. And after 13, both of them are economic. But here also we have another line, that is 17 almost. Before 17, the right lane project has higher net present worth. So if the age of the project is between 12 and 17, right turn lanes should be chosen. And if it is bigger than, it is larger than 17-year-old, as you can see, and of course the numbers that I'm telling you are not accurate, I'm just reading the chart. And if it is longer than that, the left lane project becomes more economic. So now you just did sensitivity analysis, you just did break-even analysis, that at one point these two projects are the same. At one point these two projects are the same at about 17-year-old. Before that, right turn is selected, and after that, left turn is selected. You have also learned how to calculate these exact numbers. For example, when here it says 11.8, how to calculate exactly that one. You have learned about incremental analysis. You already know a lot, believe me. Trust what you have learned so far and tackle the challenges that you are provided in this course with confidence. Let's check together a sensitivity example in which we are changing a number of, or we are changing multiple variables, multiple attributes. It is not like break-even analysis that we just change one variable. For example, life of the project or interest rate. In this sensitivity analysis that we want to check together, we are going to change multiple parameters, multiple variables. So it can be called what if analysis. Why it is called what if analysis? Because you are changing several variables and want to see what will happen. And thanks to the great platform Excel is providing us for doing our financial assessments, financial analysis, it's a quite easy job to do. So, like always, I encourage you to do exactly this example that you see in front of you, also yourself on your Excel sheet. But here we have a case. It is just one case. And the case, the initial estimate for these costs are 70,000, 1,200, 25, 8, and 12%. But my point, the point I want to tell you is that why here it says initial estimate? We didn't have such term so far, because now we are doing sensitivity analysis. So everything is estimate. So now we have just initial estimate, and we are gonna change it and do our sensitivity analysis. So makes sense seeing this word here. So this $70,000 here is just an initial estimate. It is not a finalized one, or it is not something that we can say it is certain. The number of units that being manufactured, the number of units that being served, serviced, or anything is 1200. Again, we are not sure about that. And net unit revenue, the initial estimate is $25, and life of the project, our estimate is 8 years, and the interest rate is 12%. So in our what if analysis, we want to see, for example, I'm asking you, we are in a meeting and you have done the report and you have given us this BC ratio, and I strongly encourage you to do this example also. Each example, each exercise you do deepen your understanding of the topic. Be sure that each example has one extra point to learn. So do it and see if this B over C is correct. And also when you are doing B over C correct, again, you need to remember. Again, you need to refresh your memory, and that's great in the process of learning. So you do that, and in the meeting, you said, oh, the B over C ratio is 2.13, and it seems that this project is perfect, and we need to go for that. Another person in the meeting says that the cost that you have considered is very optimistic. Adjust it to plus 10%. So after adjusting it to 10%, it is not 70,000 anymore. It would be 77,000 after the adjustment. How you are going to do the adjustment? It says 10% add to this. So 70,000 here we have, and 1 plus 10%. That's the reason I'm encouraging you to do it on your own from scratch, because you need to go through all these calculations and learn. Sometimes you have forgotten some of the details, some points, and that quick refreshers can be very helpful. So in that way you calculate that. Another thing, it says that the units that you are considering we are producing per year is 1200. It's very optimistic. If you are considering there is no power outage, there is no problem, there is no strike, there is no issue, we always have raw material. So adjust it to minus 20%. So what it is now 1200. When you want to adjust it to minus 20%, it means that you need to multiply 1200 to 1 minus 20%. So 960 would be the new calculation. Net unit revenue, again, another story, and it is optimistic. Go with this. So these calculations on the right, these new adjustments, are pessimistic, because here we have an optimistic, and here we are going to do pessimistic, and also we are going to do another one that is most likely. But here, as a practice, you do, and for 25 you do the same. So you are going to say the net unit revenue is 21, and the life in years you are considering 8. They tell you no, now the competition is very high and they don't think that the project can survive for 8 years. So let's consider it as 5 years. That's what if analysis. Again, you see how much the texture of the topic is managerial, how much it is high perspective on the issues. We are not talking about calculations. We are not talking about the details. Did you notice that? We are just reusing what we have learned in another way, in a more managerial, in a smarter way. Today we didn't discuss any new formula or things like that. We are just doing our analysis based on different scenarios, based on the fact that none of the numbers that we are specifying in our analysis are for certain. So we need to consider them in our analysis. So we came up with the topic of sensitivity analysis, break-even analysis, and now we are doing what-if analysis. And you see, we are at the same time changing multiple variables. So, and also about the interest rate, oh, they leave it alone. It's gonna be 12%. So based on that, they do B over C, and they come up with the ratio of 96%. So you see, in the optimistic way, the project is suggested, approved, but in a pessimistic way, the project is not approved. So it is one of those difficult situations. Why, my friend, it is a difficult situation? Because under the sensitivity analysis, you have received different answers. We have talked about this before. When it would be an easy case, when you do it under optimistic analysis, it gives you recommendation of alternative C, for example, and you do the pessimistic analysis, and again it approves the investment alternative of C. So it would be an easy choice, because under optimistic and pessimistic situation, one alternative has been approved to be the best. But in this case, when you are optimistic, it is approved, but when you are pessimistic, it is not approved. So it needs still more analysis. Please do all the things on your Excel sheet and make sure all the data that you see here repeating themselves on your Excel sheet, and in that way you enjoy a deep and thorough comprehension and understanding of the topics we discussed today.